Good morning, and welcome to, statistics. You're looking at mean, median, and mode range. You're looking at how that is laid out on frequency tables, stem and leaf plots, and line plots. So you're learning how to make those. To make a frequency table, you're given a bunch of information, a bunch of data, as they'll call it. And so, for instance, if Ronnie's Movie Theater wanted to show 20 different movies and wanted to know kind of how it was laid out on how much they grossed, okay, then what you would do is you would take that data and you would lay it out in what is called a frequency table. So you lay out a range that best suits your data. So for instance, 0 to 19,000. Notice that these receipts are $10,000. So 0 to 19,000, 20 to 39,000, 40 to 59,000, and 60 to 79,000. And then what you would do is you would take that data that's all up in here, you would count how many 0 to 19,000s you have. And we had 16 that were less than $20,000. All right? And then you would put the cumulative frequency, totaling it up, how many that you've used. You would put 16,000 there, or 16 there. Then you would count your 20 to 39,000s. Well, I only have one 20 to 39,000, so I'd put 1 under frequency. But then I would add 1 to 16 to make it 17 for my cumulative. Cumulative is the adding up as you go. Then 40 to 59,000, I had 2. 2 plus 17 gave me the 19. And then 60 to 79,000, I had 1. 19 and 1 gives me 20. So I've set up my frequency table to show how many, to show the best grossing movies, or the ones that kind of the range that was the average or above average grossing of the movies. But the question asks, how many movies had less than 20,000? Well, less than 20,000 would mean would be this line here, so it would be 16 movies. If I had said less than 40,000, then you would have looked at the cumulative frequency and it would have been 17. Okay? But since I wanted less than 20,000, it was 16. Now, stem and leaf plots are an easy way to organize your data when you have a lot of data, and that allows you to be able to look at finding the average and other things like that a lot easier. So if you're going to make a stem and leaf plot, you look at your data. So we've got all this data, and it's ranging anywhere from around 20 to 60 something. Okay? And so I need to organize my data in order so that way it's easier to put into my stem and leaf plot. So I order it from least to greatest. And the stems are going to be, since these are 2-digit numbers, the stems are going to be the tens place. So I've got anything from 20 to 60, so 2, 3, 4, 5, and 6 is what I'll write down under the stems. And then the leaves are the ones place. So I've got a 21, a 22, a 26, a 29, another 29. And so I would write 1, 2, 6, 9, and 9 for my leaves. And then I do the same thing for the 30s. 32, 32, 35, 36, 38. Then the same thing for the 40s. 50s, I didn't have anything, so there's nothing there. All right? I don't put a 0 there because that would mean 50, not 0 50s. Okay? And then 60s, I only have 1, which was 64. Now, you always put a key to show what it means, because, for instance, if these were in the hundreds, then these would be like 12, 13, 14, 15, etc. So they would be bigger numbers over here on the left as stems, so that way then you'd have the ones then as the leaves. Okay? Sometimes they make the hundreds place the stems, and then the tens and ones place as the leaves, but that's too organizing. So you always want to have your leaves as the ones place. All right, so that way you can tell when the next data is. All right, so 21, I know that the next number then is a different piece of data, so 22. All right, now the question asked, if these were running times, how long people ran, how many times did somebody run more than 45 minutes? Well, here's 45, so 47, 48, 48, and 64. So 1, 2, 3, 4 times greater than 45 minutes. Okay? Last, line plots. So if I was given all of these, if I was given this graph of data or table of data, and these are running times for the cross country or track team, and they wanted to, I wanted to organize my data better so that way I could tell like where the group of running minutes are. I could set it up as a line plot. So I draw a horizontal number line, and then I plot my times. So I ran my times from 0 minutes to 16 minutes because I have nothing greater than 16. You could have done 0 to 20 minutes. Doesn't matter, as long as you have all of your data on this number line. And then you start plotting your points. I have no 0 minutes, I have no 1 minutes, I have 1 2, 3 3s, 3 4s, 4 5s, 3 6s, 1 8, 2 12s, and 1 16 minutes. Okay? And then the question asked, which one or which number of miles was ran the most? Okay? Well, 2 miles, 3 miles, 4 miles, 5 miles, 6 miles, 8 miles, 12 miles, and 16 miles has something on it. The one that has the most is the one that's going to have the most X's. Well, I have 3 3s, but I also have 1 4, which is the greatest. So 5 miles was ran the most. Okay? Attempt the practice problems. Come in with any questions you might have.